All right, everyone, welcome back to Math with Mr. Miller. I'm going to go through another type of data representation that we have that can really help us to analyze data, especially in your IA or that you might be asked for on the IB exam. And this one is going to be about cumulative frequency curves. And the key word there is really cumulative. You'll see that a lot, especially as we go through statistics. We have a couple of different things that we do cumulatively. And all that really means is you're summing up to a certain point. And in this particular case, what we do is we sum up to that highest value. So really it's taking everything less than the upper limit of those intervals. So everything less than 20 in this case, well, that's just the frequency that we already have, and that's 16. But when we get to our next interval, we're going to now switch it to everything less than 30. Well, that's the 24 that we have in this new set, but that also includes everything from the original interval 0 to 20, because that's less than 30. And so we add in the 16 we already have, and there are 40 data points that are less than 30. Same thing with our next interval, everything less than 50. Well, that would include our previous two intervals, the 16 and the 24, plus the 19 new values that fall between 30 and 50, which will give us 59 total data points. And with our last one, everything less than 80, well, that's going to include everything from our previous three plus our eight new. So we can do that as 16 plus 24 plus 19 plus 8 would give me 67. Or what you might have noticed, and what we could do instead is we can just take our previous 59 that we already know plus the 8 new gives us that 67. Okay. And so there would be our cumulative frequencies from those values. Now, what we also can do is turn this into a curve that we can actually use to find different percentiles in our data set. And we'll show on the next page how to get those percentiles. For this first one, I just kind of want to go through how you graph this. And what we do is we take that upper boundary as our x coordinate for our coordinate point, and we take that cumulative frequency as our y value. Same thing for the next point. I take my upper boundary from the interval, which was that 30, and my y value, which is, in this case, 40. And our other 2 points here would then be 50 and 59, and 80, 67. And then we technically do have another coordinate point here, and I don't want you to accidentally forget this value because you really should plot it on all of your cumulative frequency curves. But we do technically have everything less than 0 here, which in our case, well, there were no values less than 0. Everything was greater than 0, so we would just start our graph at 0, 0. And what that will look like, okay, is I'm going to go ahead and plot it on the axes I have below. When you make your axes, it's really up to you what you want to scale them as. For the purposes of this, all my values seem to fall pretty low, as well as my intervals were pretty clear that it would be easy to go by tens depending on how much space. But depending on, the way your grid is laid out and things, maybe you go by 20s, that sort of deal. It's really up to you um, and the space that you have. I did it by tens because that just seemed easiest for the grid that I had here available to me. I'm going to start my first point at 0, 0. I'm going to go 20 and 16, and then 30, 40, 50 and 59, and then our last point, 80 and 67. And we then connect our dots and we get this really nice elongated S shape. And that will frequently be what a lot of your cumulative frequency graphs look like. Um, and what we can then do with that is we can look at those quartiles, which we'll show on the next page. What I do want to make sure you always do is you do title and label your axes as well as title your graph. So for this case, cumulative frequency Unfortunately, we don't really know where this data came from. So cumulative frequency curve for maybe this is a business was timing how long it took between customers entering the space, who knows? Or maybe how long it took between customers checking out. And so they had, 16 people between 0 and 20 minutes between them versus, and then things like that. It really just kind of depends on whatever the data was for. So um, for maybe customers checking out, my vertical axes, that'll just always be your cumulative frequency. And then our x-axis here in this case would be our time in minutes. You always want to make sure to clearly label those things, especially on the IB exam. That's a huge part of what criterion B measures is did you correctly define all your axes and variables and whatnot in your paper for your diagrams, your graphs, your formulas, your functions, that sort of thing. If you need to rewind, feel free to. I'm going to go ahead and move on to the next example, though. So you probably see off to the left-hand side, I have an example of the marks of 40 students on a test over here on the left side already put into a cumulative frequency curve, and it asks me to estimate the lower quartile, median, and upper quartile of my data set. So what I'm going to do for my Q, I think the median is going to probably be the easiest one to start with, so my Q2. Okay, our median is always going to be 50% of the data falls beneath whatever that median value is, 50% of it falls above. So what I'm going to do is I think it looks like a total of 40 test takers, yeah, marks of 40 students. I'm going to take 50% of that value. That means 20 individuals should fall underneath the median, 20 should fall above. So I'm going to go to 20 on my cumulative frequency curve. I'm going to draw a line straight over, and then when I hit the axis, or when I hit the graph, I'm going to draw my line straight down. And that is where I would find a rough estimate of my median in this case, which would looks like it would fall around roughly 56. Okay? Which means they're scoring a 56 out of a 90, or maybe 56%. Oh, less than 90. So this is probably points, not percentages. Um, so they're probably scoring 56 points. The reason I say it's probably points, not percentages, is because if it were percent, our x-axis would probably go to 100, not 90. For Q1, then I'm going to do the same process, but Q1 is where 25% of the data falls beneath. So I'm going to go 0.25 times 40, which is going to give me 10. So I'm going to go to 10, drop straight down. It looks like that's hitting at about halfway in that box there, so probably around 51 points. And then for my upper quartile, well, that's where 75% of the data falls. So 0.75 times 40 gives me 30. So I'm going to go over to 30, arrow over, drop straight down. Looks like the upper quartile there is hitting right around 63. Okay. And we can actually go backwards. Oh, percent's probably not the right word here. Points would probably be the better word. So estimate how many students scored between 60 and 75 points. I can just reverse the process that I've been doing. So I'm going to erase kind of what I have on my screen here, on my graph, because I don't want those lines to really get in my way. So if I want to know how many students, well, I'm going to find how many students scored less than 60. So I'm going to go up from 60. And that's actually conveniently marked for me. And that looks to be right around 27-ish, 28. I think there was about 28 people. So 28 scored less than 60. And I'm going to do the same thing for 75. So right up that line there. I'm going to hit my line, go right over, and that looks like it's going to be 37 people scored less than 75. And so if I want to find how many people are exactly between 60 and 75, I will subtract those values. And that's going to give me 9 people, it appears, have scored between 60 and 75 points. Okay. And again, as always, if you have any questions, please feel free to reach out. I'm more than happy to help. You're welcome to come in anytime that I'm available or reach out to me via email. And then same thing, just reminder, because this is a diagram, if you were to use it on the IB exam or use it in your IA, you always want to make sure it's titled and you have your axes labeled clearly and that sort of thing so that it's very easy to read, especially if you're going to be using it to interpret some values and data in your paper. All right, have a great day, everyone, and thank you for watching.